Hi, this is Nathan Wynn from Inomatic. Today I will go over the Sudoku solvers that I built in VBA 6 years ago. I posted the video up in YouTube, and at the time of this recording we have 9.8 thousand views and a lot of interest in obtaining the files. I personally sold 3 copies at $100 each. At the time I just named a price and the individuals were willing to pay, but today I'm open up to sell this at a much lower price, of course. If you're interested, the link in the comments. However, I will go over the codes and my approach. Not necessarily line by line, but should be enough for you to take on this project should you choose to do so. Let's get started. First, let me solve a puzzle for you to see. If I click reset, it will just clear out all my numbers that I enter. For example, let me show you 2, 1, and I reset, it will just clear out the numbers that I enter. If I clear board, it will remove everything. I go to the puzzle tab. I have a field here for you to copy. Right click, paste it value. Now I need to mark the default red by clicking that. Now if I am to reset this board, the original numbers stay. If I click on solve, and just like that, we got the result. If I click on this cell here, it will highlight the numbers and it will tell you the reason why 5 was selected, because the only possible cell for this number to be entered, because 5 cannot be anywhere else in the remaining 2 blanks. So far we have gone through the 3 buttons that you can possibly click. Reset the board, clear board, we will just clear out everything for you to enter the new puzzle, and default red will make the starting numbers red, so it won't be clear out when we reset the board. Up here are the 2 techniques that we use to solve. First is the annotation. When we click annotation, it becomes minus, and it will enter all the possible numbers that a cell can hold by looking at cross, down, and within the 3x3 grid. We can run the naked pair, and naked pairs can only be run after we run the annotation. Let's take a look at the naked pair. So naked pair in this 3x3, the last one, we have 3, 5, 3, 5, 3, 5, 2. If I run the naked pair, it will remove the 3, 5 from here because it knows this 3, 5 will occupied by these 2. Therefore, a 3, 5 will not be possible here. That will leave 2 is the only choice. And let me prove that to you by running the naked pairs. And you can see it removes similar numbers across the board for us. When we try to solve the puzzle and by looking down across and within the 3x3 it cannot solve, it will run the annotation naked pair and then try to solve it again. Let me show you one puzzle where it has to do that. This one right here is a hard puzzle. Copy. Oh, I should have clear first. Let me clear the board first. Copy again. Paste. Mark default. Solve. You can see it takes a little bit longer. Looking at the strategy log, it goes to this point and it say I cannot go any further. It will run the annotation, the naked pair, and then it will attempt to solve the puzzle again. Going down the list, and it was able to complete. I like to name my range, and in this case, it is essential. Otherwise, I cannot loop through. For example, here, this entire 9x9, I name it Excel puzzle. But this entire 9x9 is made up of 9 separate 3x3. So this I name group G for group 1, group 2, group 3, group 6, group 9, right? It's in that order, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, once you have these 9 independent groups that make it this puzzle, how do you loop through? You simply just do the indirect name of 0 and then just loop 1 through 9. You can evaluate all 9 in a single action. But there's more than just these 3x3. They are in column. They are in rows. This is XLR row 01, row 02, rows 4, 7, 9. What about column? What do you think this is? Column 7, column 9. So we can loop and evaluate this by rows, by column, and by the group of 3x3. But we need to know the individual cell. This one right here, where do you think it is? It is in group 2, row number 3, 03, and it's column number 5, 1, 2, 3, 4, 5. So each of the cell has its own address, where from that address I can know what group it belongs to, what row, and what column. This is essential to be able to evaluate the puzzle in the most efficient manner. This button here is assigned to subroutine solve puzzle. If we pull up the solve puzzle, we see that it set the range message to blank. Range message here is where I display information to the end user. I use that instead of the dialog box, which I don't like. Then I set the range whole puzzle to the range Excel puzzle here. I showed you earlier, I named this 9 by 9. The entire thing is Excel puzzle. So when I reference that, I reference all 9 by 9. Then I set the variable all empty equal false, and it will do the loop. It will do loop while all empty is true. And so among this condition, when it's appropriate time, I will set it to true and it will break the loop. For now, the first thing it does is say move count to 1. That's the starting point. Then it call the function elimination and then call only choice in range. For now, let's just call elimination and then end it there so that we know where things start. Let's proceed with the run. If we click on solve, we get about 10 plus numbers within half a second. And I would like to know how this number 7 was determined. In elimination function, I started a for loop of a group count from 1 to 9. And you can see where's the custom name become important. And here we have first 3 by 3 is XLG01, XLG02, all the way to XLG09. When I have a for loop from 1 to 9, I can set the range of the group equal range, this XLG underscore 0, and whatever the for loop count start with 1. So of course we're gonna evaluate group 1 first. Then I set the cell available count for I number equals 0. And it's a mouthful for a variable, but because I'm explaining to you, it needs to make sense. So I'm counting the cells available for whatever this I number is, start with 0. And so when we have a block that has cell available counts more than 1, then that is not the answer. We cannot solidly determine that is the only number that should go there. Number to enter in cell is blank, but generally speaking, it's always equal to this I number. We're gonna have the second for loop here, actually the third for loop. For each cell within the group, in range group, so for each cell within the group, if the cell value is blank or the size of the font is 9, then it is virtually blank. The number exists false. There is no real number there. Why 9? If I run the annotation, this number here have a font size of 9, but do we have the answer for it? No, it's not solidly an answer because it's just an annotation. We need to go in there and type in the number. So we take out the annotation. Go back here. So when it's blank or have a sign, the number doesn't exist. I take the cell within that group and set it to current cell. So now I know, for example, in this case, it has to be D4. Let me clear the board first. D4 is the first cell to be evaluated because it is blank. I then try to get the custom name of that cell. So cell custom name equal current cell, D4 in this case, dot name dot name. Dot name dot name will give you the custom name, and I will show you that is in fact the truth. If I message box cell custom name, go here, click solve. Here's the dialog G010102, group 1, row number 1, column number 2. Once we know the cell custom name, we call get cell position function. I should pass this cell custom name when calling this function, but because this is a public variable, it already has the information that I need to pass this down here. So the cell custom name would have this value here. I basically extract the group number, the row, and the column by using the mid function. Here you can see the column is the last 2, so the last 2 from the right. Because these are standard length, so the mid can be used a fixed number here. Once I know the group number, row, and column, I then set the range group to that. So at this moment, we know from this D4, we know it's group 1, row 1, and column 2. Going back to the code, I set all range and I join the 3 range that we just set using the union function. When that is done, I loop through the all range. If the font size is not 9, meaning it's not an annotation, and the cell value is equal to whatever the number that we are evaluating at the moment, starting with 1, then the number exists. Because the cell contains that number, we don't need to do anything further. We can skip that number or this cell. Up here, we have a variable called inum exists when we set it to false. In this case here, when it's true, I change it to true. If it remains false, meaning the condition here is not met, we move on. If exists is still false, we increment the cell that are available for this inum starting with number 1 by 1. Okay, and I go ahead and capture the number 1 and the current cell. The inum or number to enter in cell will not be used unless cell available count is just 1. So after we loop through all the possible cells within that range, all range, and the available count is 1, we go ahead, enter the number to enter in cell into the cell location that we capture up here, and we increment the move count by 1, and then we log the reason why we enter or select that number for that cell. I know it's a bit confusing, but not to worry. I have a way to show you logically with these two here. So I'm selecting the all range, so you can see the range that the application is evaluating and the numbers that are being used for the evaluation. Let's proceed with clicking the solve button. Here we have a dialog telling us the cell evaluating is D4 and the range, this group, row, and column is being evaluated. I number is the number that we're starting with and the number of cells available for the I number. So I'm going to click OK real fast so you can see the transition between the loop. What it's doing is it's just going through the available cells within group 1, but when it's evaluating, it will look across the rows and the column as well. Let me click real fast here so you can see the transition. You can see that it's moving across. Alright, now it moves to group 2. In the first group, it was able to enter a number 7 here. And when we look at it, it makes sense a 7 must be here. But let's slow down and go to number 7 and see how it was determined. Reset board, click again. I'm clicking through. Pay attention to the I number and the cells available count. 0 available for number 1, 0 available number 2, 1, 2 available number 3. Number 4, 0 available for number 4, 1 for 5, 2 for 5, 3 for 5. Because it's greater than 1, the number cannot be determined, so we skip. 6, 1, 6, 2, 6, 3, 6, 7, 0. Still 7, 0, 7, 1. So it found a spot for 7. Still just one spot. Still just one spot. And move on to 8. Because there's only one spot, is 7 can be entered in this group 1. Therefore, it placed there. And as previously ran, nothing for 8 and 9. But that should show you visually what the application is doing. Let me turn off the message box, but leave the range selection there. We will exhaust the function elimination and end it there and see how far we get with the board. Go here, the board already reset, click solve, and just like that, we got over 10 number filled in. However, it's not enough for us to complete solving this puzzle, and that's why we need to activate this only choice in range functions. Here it is, and we are going to evaluate this since it is looking through the entire puzzle and it determines if the cell is blank or it has a font size of 9, then it is for evaluating. If the font size is not 9 or it has value, meaning it's already filled, there's no need to do anything with it. For each of the cell that we loop through, we get the custom name. We call the get cell position. We are not evaluating the local group of 3 by 3. We only loop through the row and the column. That's why we only have 2. If it's 1, we loop through the row first. If it's 2, we loop through the column. Blank cells here, it will look across and then it look down. Okay. So other than it looping through each empty cell, the next nested for loop is to loop through the row and the column. Within the row or the column, it will go from 1 to 9 in terms of the number. It determines the row or the column range. It counts for empty cells. If that entire row or column does not have any empty cell, then it exists 4. This is the limited redundancy because we would never evaluate anything that doesn't have a value. So this is almost unnecessary. But otherwise, for any of the empty cells, we put everything into an array. And within that empty array, it will loop through again. So I have a message box here that actually gives you the same feel and visual as we had previously in the elimination function. That for you. and rerun the code. If we run this, we finish the elimination and it goes to the next function. And here's the dialog. We're looking at the row first. As we previously examined the code, there are 3 blank cells, and the 3 numbers for these 3s are 3, 5, and 6 in no particular order. It will evaluate number 3 first. A 3 can fit in here. The 3 can fit here, so that's why there's a count of 1. A 3 can also fit here. That's why there's a count of 2, and there's a count of 3. So we will not gonna try to fill anything with number 3 at the moment. Go on to 5, 1, 5, 1, 5, 1, 5. So a 5 can be selected somewhere, and it places a 5 right there because a 5 exists here and the 5 exists here. Therefore, the only possible cell for this 5. 6, 1, 6, 2, 6. It will skip first row, it go on to the second row, and we're looking at 3, 4, and 6 for these 3 blanks. I think it does not evaluate the column, or maybe with just the group, because 3, 4, and 6, 3, 4 already exists here, so the 6 must be here, but the application does not recognize that. It will eventually get to that point, but I thought 6 can be placed here right away by looking down the column. So hopefully you will improve upon this if you purchase a copy of this, right? Isn't that cool? You will, right? All right, let's proceed. So we'll look at number 4, 0, 4, 1, 4, 2, 4. So you get an idea, okay? It will do so across and then go down. And if it cannot figure it out, it will run the annotation as well as the naked pairs. If I take away the message box and rerun the code, it gets us to near completion because we put a stop after we run the only choice. If we are to keep going after it run the elimination and the only choice function, clear, reset, it should be able to solve the puzzle because I think it get all the way to this point with the only choice, then it rerun the elimination using additional numbers that we have. And with that alone, it's able to solve this easy puzzle. Though, as seen earlier, there are improvements to be made, and I hope you purchase a copy and try to improve it. When you do that, I will briefly show you the code for the annotation and the naked pair, and then we're gonna end the video there. It's getting long, and so as you know, every single minute is required editing, and I don't enjoy the editing part too much. So let's get to the last 2 functions. Looking at the annotation subroutine, you can see it's not very long. First thing, we change the screen updating to false so that we don't see the flickering. We would then extract the text of the save name button annotation, this one right here. It has right now as annotation plus. If I click that, it will run the annotation and it changes to minus. Therefore, the text on this save matters. That's why we need to extract it and know what it is. If I click it again, it clears out. I'll show you, I can get that name, annotation plus. Now, I set this range whole puzzle to range Excel puzzle, and I look through for each cell within this range. If the button is annotation minus, meaning annotation already ran, and so any cell that has a font size of 9, we need to clear it and set the font size back to 26. If it's not minus, meaning it's plus, and that's in this else. If the font size of the cell is 9 or blank, we treat it as blank. We need to know the cell by getting that location. Get the cell custom name of the current cell, and then we go ahead and call the get cell position. Once we have cell position, we call the annotation add, and this function here. Like before, we joined the group, row, and column range in our name. We loop starting from 1 to 9 of the 9 numbers that can be used in a cell. We set the inum exists to false. In each of the cell, if the cell value is equal num, meaning the number exists, we change to true and we get out. And this part of the code will not execute. It loops back through. When the number does not exist, which is false, then we set the current cell value to current cell value and the I number. So we pretty much concatenate whatever on the cell to the I number, and of course a space in between. And we change the font size for that to 9. when we're done with this annotation add here, we continue to loop through. If the annotation text is annotation minus, then it's changed to plus, and vice versa. This is simply just a toggle, and then we change the screen updating back to true. The codes for naked pairs isn't that much either. Here we graph the whole puzzle. We loop through it, detects any cell with a font size of 9, meaning it has been annotated, and the length of 2. Then we graph the cell, we get the custom name, we call the get cell position. Remember, this here will return us the range of the 3 by 3. We call that group, right? The row and column. After we did that, we call naked pair action, which is this function here. We combine the 3 range together into this all range, and then we loop through. If the current cell which capture up here isn't the same as the cell of this range here, and they are the same, they have the same values in it, then we proceed with setting the pairs found, and that really should determine the range and replace the numbers of the pairs from the PT cell. So in this case here, let me show you. We'll have to run the annotation first. Let me turn off the message box. Go back here. Now let's remove the naked pairs. You can see here is 3, 4, 3, 4. So they will remove this 3 here, remove 3, 4 here. Watch. See that? It happened. So now if we loop through, we can easily figure this is the 1, this is the 7, and this is the 6. That's it for me. I hope you find it entertaining. The link is in the description if you would like to buy the file to support me. Otherwise, I will see you in the next video. Goodbye now.